Geometric series is a little bit harder formula to work with, but still not too bad. I want to develop this formula. The way that I develop the formula is I list out all of the sums of a geometric sequence and add them together. Now notice that my first sum is regularly listed, and what I want to do is somehow be able to subtract out all of these middle terms. The way I can subtract it off is by multiplying this sum by r, and when I multiply by r, a sub 1 becomes a sub 1 plus r. This becomes a sub 1 times r squared, etc. And I'm lining them up this way because now you can see when I subtract it, I can just eliminate all of those terms except for two terms that remain. The first term is going to be this one, and the last term is going to be this one. And that's why you have a sub 1 minus a sub 1 times r to the n. And I can factor an s sub 1 out, an s sub n out, and I'm left with 1 minus r. Again, you distribute and get up above it. And I can factor out a sub 1 on the right side and get 1 minus r to the n. Distribute, I get what's above it. Then if you divide both sides by 1 minus r, the remaining is going to be that top equation. And you get the second equation by distributing through and then a substitution. So let's go ahead and solve some of these problems. Find the sum of the first 7 terms. So I want to go ahead and use the second, this first formula because I don't know my last term. So I can use that first one. The sum of the first 7 terms equals the first term, 1 minus. Now I have to remember, what am I multiplying by? I'm multiplying by 4. So it's 4, and n is 7. And then I want to divide by 1 over 4. So to do this, I would figure out what this is, divided by 1 minus 4, or negative 3, and then multiply by negative 1 to get my s sub 7. So that's just order of operations after that point. Let's look at the next problem. So find the sum of the geometric series if you know the first and the last term. First and last term. So now I go to the second formula to help me out with this one. So I'm going to find the sum of the certain number of terms is equal to 8 minus 0.394 times 9/11 all over 1 minus 9/11. And that would give you the sum. Don't need to know what you have. Well, it's a lot easier when it's given you the last term to use the second formula, because as you can see in the first formula, you don't have that last term. And the last type of problem is this type of problem where it's in summation notation. And so again, I guess the easy thing to do is to see that you can get the first and the last term relatively easily. So I'll just do that second form as well. So the first term is where you put 1 in. 1 becomes 0. This to the 0 power is 1, which is just 5. So it's going to be 5. And then it's minus the common ratio, which is just going to be 1.06. And then again, I'm looking back up here, and it says common ratio times the nth term. So the nth term is where you put 11 in here. So that's going to be a little bit more confusing. So it's 5 times 1.06 to the, if I put n is 11, so that's to the 10th power. And then I'm going to divide that by 1 minus r, which means that it's the whole thing divided by 1 minus 1.06, and that's going to give me my sum. Very important on this last part, geometric series, is to realize that both formulas are essential in doing these. Look and see what the givens are and choose the formula which makes best for the sum of the geometric series.